Hey guys, thanks so much for tuning in. Today we're going to be looking at 3 different ways of solving systems of linear equations. The first method is graphing. This is a little bit of a review. So here's our system. Our first equation, y equals x plus 1. And our second equation, y equals negative x minus 3. We're so lucky. In this situation, both of our equations are solved for y, so we don't have to do that first step. So let's start by graphing. I'm going to graph my first line in blue. So let me just box that in blue so you know which one I'm referencing. For this equation, remember it's already in slope-intercept form, which means that my slope is technically a positive 1 over 1, and my y-intercept, always in ordered pair, is 0, and then this number, a positive 1. Let's start by plotting that point. So from the origin, I'm going to go up 1, there's 0, 1. I always like to put it in there. And then from this point, I'm going to rise 1, run 1. So I'm going to go up 1 to the right 1. I'm going to continue to do this until I do all the points on my graph. Then draw my line. Alrighty. Second equation. I'm going to graph this one using a black marker, so you will know which line this is. All right, for this equation, my slope is going to be a negative 1 over 1. And then my y-intercept is going to be 0, negative 3. So let's start there. From the origin, I'm going to go down 3 and put my point. Then from there, I'm going to go down 1 to the right 1. Down 1 to the right 1, down 1 to the right 1, until you can't go any further. And draw my line. Not perfect, but I can definitely see where they intersect. Let me get a third marker here. I see these 2 points intersect right here, and I'm going to identify what that location is. So from my origin, I'm going to go to the left 2, which means that my x coordinate is going to be negative 2, and then I'm going to go down 1, negative 1. So to the left 2 and down 1, negative 2, negative 1 is my solution. So when we do the other type methods in order to solve this, I should get the exact same solution. I'm going to rewrite my equations here just so I have them. So it's y equals x plus 1 and y equals negative x minus 3. And again, before, when I graphed it, I got this solution. So as I look at the other 2 methods, that's the same solution I should get there as well. Let's look at the other 2 methods. Alrighty, let me erase here. And you can see why I needed to rewrite my equations, because I'll need them here, but you already have them on that paper. So let's look at substitution. I'm just going to make sure that these are, you can see everything on the board. Alrighty, so I have my 2 different equations set equal to y. Let me get nice and big there. Since I have it like that, when I substitute one in for the other, it's probably going to look something like this. If my x plus 1 is equal to my y, then that should go in right there for that y. So I'm going to rewrite the bottom equation, but I'm going to replace this y with that. So I have x plus 1 equals negative x minus 3. I'm going to throw a 1 in front of those x's just so I know the coefficients. Now I need to move stuff. I'm going to take this x and add it to the other side. That goes away, giving me 2x plus 1 equals negative 3. Next, I'm still trying to get this x by itself, so I need to subtract 1 on both sides. 2x equals -4, and when I divide by 2, x equals -2. All right, so far so good. Now that I know what this equals, I'm going to substitute that back into the other equation. And really, I can pick either one, so I'm going to go right up back to the top one. So this number is going to go in right there. So I have y equals, instead of my x, I'm going to put in -2 plus 1. -2 plus 1 equals -1. So there we go. We got the same answer. So far, so good. Let's try it one different way. Elimination. I'm going to rewrite both of those equations again, right on top of each other. So y equals x plus 1. Y equals -x minus 3. With elimination, we want to make sure everything's lined up. Typically, we like it in this order. ax plus by equals c. But in this case, they are lined up. They just look a little bit different. They're both in slope-intercept form. And that's okay. It's not going to be a big deal. Just to make sure that I know that what my coefficients are, I'm going to put a 1 in front of anything without a number. Next, I look for the opposites. These aren't opposites because one of them would have to be a negative. But I have a positive one and a negative one. So if I added these two together, my x's would eliminate. Now I can add down. 1 plus 1 gives me 2y. 1 plus -3 gives me -2. So when I divide both sides by 2, I get y equals -1. Now that I have that information, I can plug that back into one of the two original equations. I'm just going to go with this bottom one here. So I have -1 equals -1x minus 3. Next, I'm going to add 3 to both sides, giving me 2 equals -1x. When I divide by -1, x is going to equal -2, giving me my final answer of -2, -1. Not too bad. We solved it 3 different ways. All right, let's try this one more time using a different system. I'm going to just move here we go. Here's our next system of equations. So like I said before, we're going to graph first. We're going to graph first. For my first equation, I'm going to do this one in blue. I'm not going to box it because I'm going to need to manipulate it a little bit to put it into slope-intercept form, which I know is y equals mx plus b. I'm also going to rewrite those equations over here so I have them for a little bit later. Alrighty, so in order to graph these equations, I'm going to need to solve for y. Right now, on this side of the equal sign, I have the 2x. So I'm going to need to subtract the 2x on both sides, which would leave me with y equals -2x plus 1. For that one, my slope would be a -2 over 1, and my y-intercept would be 0, +1. Let's start there. So from my origin, I'm going to go up 1. There's 0, 1. From that point, I'm going to go down 2 to the right 1. So from here, I'm going to go down 2 to the right 1. And let's draw our line. Alrighty. Same thing with this second equation. I'm going to need to manipulate it a little bit. I need to solve for y first. So again, I'm going to subtract 2x on both sides, giving me y equals -2x minus 3. My slope again is a -2 over 1, but my y-intercept this time is 0, -3. So I'm going to start there. From my origin, I'm going to go down 3, put my point, Then from that point, I'm going to go down 2 to the right 1. And draw my line. Now I could tell before I graphed the lines that these were going to be parallel lines and that they were never going to intersect. The reason I knew that was because they had the exact same slope. And I know that parallel lines have the same slope. And since these two lines are never going to intersect, that means our solution is no solution. So that's how that would look if we graphed it. But how would it look if we use substitution or elimination? Well, let's find out. Alrighty, substitution. Again, I'm going to rewrite my equations, get rid of all this. In order to substitute, I need to solve for one variable first. It doesn't really matter which one I go with, but I'm just going to pick this one. See how this y is by itself? It's going to be easiest for me to get this y by itself because the only thing I'll have to do is get rid of the 2x. To get rid of the 2x, I'm going to subtract it on both sides. That's going to leave me with y equals negative 2x plus 1. All right, I got what y equals. Now I need to substitute that into the other equation for the y. So I'm going to draw my arrow and then substitute it in. Right below I have 2x plus, that's where I'm going to put this guy in. Negative 2x plus 1, going right back up here, equals negative 3. Well, let's combine like terms or clean it up first. We have a positive 2x and a negative 2x, which completely cancel each other out. We have a positive 1 equals negative 3. That's not true, which means no solution. One more time, elimination. Again, I'm going to rewrite these. All right, in order to eliminate, I would need the opposites. So if this is a positive 2, I would need this to be a negative 2x. Since this is a positive 1y, I'd need this to be a negative 1y. I don't have that situation. So I'm going to need to multiply the entire equation, one of them, it doesn't matter which one. I'm going to multiply the top one by negative 1. When I multiply that straight through, all that's going to happen is I'm going to change all my signs. So it's going to become a negative 2x minus 1y equals negative 1. Now I can add them together. And as you can see, this is gone now because I've rewritten it there. All right, from here, I can eliminate my x's. Gone. But also, my y's eliminate, leaving me with 0 equals negative 4. Again, not true. No solution. Thanks so much, guys.